Assalamualaikum and hi everyone. I am ADDINA NADHIRAH from Group 4 and this is my group's member. We have FAIHA, QAISARA, SHARMILLA, ISSHITHA and Muhammad Adam. So we will present for Mission 4. To complete Mission 4, first we have to understand these three topics which are amplitude modulation, angle modulation and radio digital modulation.
So, in this video, we will explain for the data transmission, modulation types, baud rate and bit rate, increasing bit per baud, QPSK and QAM, and the last one is the benefit in the communication fields that related to all of these topics that have been explained.
Assalamualaikum, I am Adina. I will present about the data transmission. The definition of data transmission is the transmission of signal that contains the information from one digital device to another through a channel of communication such as phone cables or satellite. And this transformation requires a shift in frequency signal to a certain suitable range. This shifted frequency can be achieved by modulation process. The modulation process will shift the frequency of original information signal from low frequency to high frequency by using carrier signal. In other words, the modulation is the changing of the carrier signal characteristic according to the modulating signal.
Okay, we continue to the types of modulation. First of all is amplitude modulation, which is the function is to change the amplitude of the carrier signal according to the instantaneous information signal. And this type of modulation is very simple and low cost, low spectral efficiency, prone to interference and noise, and also being used in radio broadcasting. Okay, next is frequency modulation. Frequency modulation was produced when the instantaneous angular frequency of the carrier signal is very linearly according to the modulating signal. This type of frequency is very high fidelity, high noise immunity, more complex than amplitude modulation, and widely applied in very high frequency and ultra high frequency radio broadcasting. Okay, for the last one is phase modulation. Phase modulation occurs when the angle of the carrier signal is changed according to modulating signal. These types of modulation is high spectral efficiency, more complex than amplitude modulation, prone to phase noise and used in digital communication systems.
My name is ISSHITHA and I'm going to explain about bit rate and baud rate. Bit rate is expressed in bits per second, represent the rate of data transferred over a communication channel within a specific time frame. It measures how fast the data travels from one point to another. Higher bit rate allows for faster transmission of information. So it is calculated by multiplying the number of bits transmitted in each unit of time. For instance, if a system sends 1000 bits in 1 second, the bit rate would be 1000 bits per second. So bit rate is crucial in digital communication, networking, and data transfer. It determines the audio and video and internet connection speed quality. Baud rate is measured in baud, signifies the number of signals per second transmitted in a communication channel. Each symbol represents data and in some cases multiple bits can be encoded within a single symbol. So unlike bitrate, which directly measures the number of bits transmitted per second, baud rate measures the number of signals changes per second.
Baud efficiency, also known as increasing the bit rate per baud, is a technique used to increase the amount data that can be transmitted in a given amount of time by packing more bits into a single symbol or baud. This is achieved by using signal encoding techniques that enable multiple bits to be transmitted in a single symbol. Some of the most common encoding techniques used to increase baud efficiency include: first, frequency shift keying. FSK encodes digital data by changing the frequency of a carrier signal. In order to increase the baud efficiency, FSK can use more than two frequencies, allowing more than one bit to be transmitted in a single symbol. This technique is commonly used in modems and other digital communication systems. The second method is phase shift keying, PSK. PSK encodes digital data by changing the phase of a carrier signal, like FSK. PSK can use more than two phases to increase baud efficiency, allowing more than one bit to be transmitted in a single symbol. PSK is commonly used in wireless communication systems such as Wi-Fi and Bluetooth. Last method is amplitude shift keying, ASK. ASK encodes digital data by changing the amplitude of a carrier signal. ASK can use multiple amplitude levels to allow more than one bit to be transmitted in a single symbol, thereby increasing the baud efficiency. ASK is commonly used in remote controls and other basic wireless devices.
I'm Sharmila and I would be explaining about QPSK, which is known as quadrature phase shift keying. It is a digital modulation scheme used in radio communication to transmit data over a carrier wave. The term quadrature refers to the use of two carriers that are 90 degrees out of phase with each other. In QPSK, each symbol represents two bits of data, and the four possible phase shifts correspond to the four possible combination of these two bits. The four phase shifts are typically 0 degree, 90 degree, 180 degree, and also 270 degree. QPSK has two PPSK system which has 90 degree phase shift between them. It is separated into two, which is channel 1 is PBSK with a phase of 0 degree and 180 degree. The second one is channel 0 is PBSK with a phase of 90 degree and 270 degree. Next, I'll be explaining about QAM, which is quadrature amplitude modulation. It is a digital modulation scheme that conveys data by varying both the amplitude and phase of a carrier signal. It is widely used in telecommunication and data communication for transmitting digital information over radio waves or through other media. In QAM, amplitude and phase of the carrier signal are modulated to represent multiple bits per symbol, allowing for higher data rates compared to simpler modulation schemes. The term quadrature in QAM refers to the use of two carriers that are 90 degrees out of phase with each other.
Now, I'm going to explain about misconception that we often heard about amplitude modulation, angle modulation, and radio digital modulation. For amplitude modulation, we have heard that AM only transmits audio signals. It can also actually transmit other types of signals, including digital data and analog video. So the next one is FM is immune to noise and interference, which is it is not actually entirely immune. Strong interference or close proximity to jamming can still disrupt the signal. Last but not least, for the radio digital modulation, DRM is just another analog modulation technique. It is actually a digital radio broadcasting standard utilizing techniques to provide robust and efficient data transmission and digital audio and data.
Next, I'll be explaining about the latest technology, which is Internet of Things, also known as IoT. It refers to the network of physical objects or things that are embedded with sensors, software, and other technologies. It is to connect and exchange data with other devices and systems over the internet. The primary goal of IoT is to enable these objects to collect and share information, facilitating intelligent decision making and automation. There are a few benefits and impacts of this IoT technology. For the benefits, it has improved efficiency and productivity, better resource management, innovative and new opportunities, and also improved safety and security. For the impact of this IoT technology, the first thing is cybersecurity threats, privacy concerns, digital divide, and also environmental impact.
In summary, the Internet of Things is like giving everyday things from fridge to cars a way to talk to each other through the Internet. It makes our lives easier and more efficient, but we need to be careful about things like privacy and security as it keeps growing. Finding the right balance will be a key for a smart and safe future. Thank you.